Alright, so here's the third part of this problem. Our function is here, and our operator is here. The book doesn't use O caret. Okay, I'm just using that to remind you what's going on here. Sort of organizing that for my own head. What I'm going to do then is I'm going to take this function and just take the fourth derivative. I'm going to take 4 derivatives with respect to theta. So the function is sine 2 theta cosine phi. And the first derivative of that is d theta, of course. And I'm going to go, well, you know, this is just a constant with respect to theta, right? There's no theta in that term. So I really just have to do the derivative of sine 2 theta with respect to theta. Now, there's a couple things to do here. Number one, I have to do a u substitution. Sorry for the background noise. I have to do a u substitution. And number two, I've got to remember what's the derivative of sine. Now, probably many of you have that memorized. Many of you already have that memorized. But frankly, I don't. So what I'm going to do is I'm going to show you how I remember that. Okay? So what I do is I'm going to build a sine wave here. That's from 0 to 2 pi. And then a cosine wave I'm going to do as a dashed line. It goes there. It has a minimum here, right, and a maximum here. I'm sorry, the other maximum is here. Okay, goes to 0 there. Okay, so this is cosine of theta, or x, and this is sine of theta. If this is f of theta, and this is theta, right? There's my axis is f of theta and theta. Okay. So I look at this and I know the slope at this point. This is my sine theta, right? And I know the slope at that point is 0. So it looks like the d theta of sine theta might be simply cosine theta, right? But I'm going to make sure I've got this right. At 0, looks like my slope is believably 1. Sure, I can see that that's 1. It's more obvious that it's 0 at this point, okay? And it's 0 at this point, so sure enough. The slope at this point, the slope of sine theta, is 0, which appears to be cosine theta at that point, right? So yeah, it looks like this is the correct formula for it. But let's do the negative one here. I can see that the slope here is negative something, right? You can't tell it's negative 1, but this here is cosine theta. That is negative 1. So that is believably negative 1. So indeed, that's it. Now when I'm doing this is what I always use for my reference. So if I'm supposed to find, for example, the integral of sine theta d theta, I'm going to remember that that's minus cosine theta, because I guess I skipped a jump there. I skipped a step. The integral of cosine theta d theta is sine theta, because the derivative of sine theta is that, right? Remember that? That's really basically the rule of integration. That's what we mean. So that's how I remember it. Of course, I think most of you are going to want to simply memorize that that the derivative with respect to the derivative of sine is cosine. Okay. Now I'm going to do a u substitution here. Let u equals 2 theta, then sine u is equal to sine 2 theta, right? So du sine u is equal to cosine u, right? And du d theta is equal to 2, right? From that point there. Okay, so it looks like the first derivative of this is going to be cosine phi, because that's just a constant. I'm sorry, f d theta is equal to df du. Du d theta is the chain rule, and I always have to think this out, okay? So du d theta is just 2, because I have it here. And df du, that's f now, is cosine u. Cosine u, which is 2 cosine 2 theta. I just brought the 2 out front. That's times, right? okay, times cosine phi. Okay, that's df d theta. That's assuming that this is my f, which I said it was, right? If that's f, df d theta is equal to 2 cosine theta cosine phi. I can roll here. My second derivative of f with respect to theta is we're going to be bringing the 2 back out again, is going to be 4 sine, or negative 4, because it's going to come out as a negative, theta cosine phi. That's the second derivative. The third derivative, theta, is going to be negative 8 cosine theta cosine phi. And the fourth derivative then of f with respect to theta is going to be, and it's going to be another negative coming out. Cosine, there's a 2 in there. Another 2 in there is going to be 16, because I'm bringing another negative out, sine 2 theta cosine phi. This first step I show you how to do. From here to here, I demonstrated that over with the u substitution. This one I didn't demonstrate, and I'm just doing these in my head now that I remember it. If you want to see a demonstration of that, you need to be practicing that stuff. You really ought to try that. Let me know if you need to see a demonstration of that. But I will tell you it's the same thing as I did up here. So the fourth derivative of x with respect to theta is 16 sine, and that again is f, right? So it looks like this is an eigenfunction. Wow, I love this game. And that then is my eigenvalue. I think this one merits a smiley face.